Can everybody see that? Great, thanks.
Yes.
Thanks, Jonathan.
Yes.
Well, first of all, good morning, everyone, and thank you very much for this invitation, Alison and Murray in particular, and in particular to give really an introduction to really a new program of work, which is, really that we need to do to transform the way we interact with the environment, understanding of the environment, and ultimately to deliver on the big climate missions that we have. So it gives me pleasure to really introduce broadly the Scotland's International Environment Centre, which, if you might have seen in some of the local press, at least, if not in social media, it was launched on Thursday this week, and there's a real programme of action moving forward there. But fundamentally, I will focus a little bit more on the fourth environmental resilience array, which is fundamentally building this platform for regional recovery. And then I'll also talk very briefly about the hydrogenation chain, how that fits into this in the bigger picture on delivering on net zero, because the fourth plays a key role in all of this. Before I go much further, maybe I'll just start go back in time a little bit to 2015, when I was still head of biological environmental sciences at Stirling, and very, very aware of the excellent research both within Stirling and across Scotland and beyond internationally around the environment, but also very conscious of the fact that there was a real disconnect between this excellent science and driving change. And then with obviously the looming climate crisis, again, very aware that actually what we need to do is solve these problems not in isolation, but actually the only way to really solve them is by bringing together the university research sector, together with government, together with the policy and regulatory community, together with industry and with communities, because it's only by working together ultimately that we're going to find those sustainable, workable, adaptable and implementable solutions that we need to do to mitigate the effects of climate change and obviously reduce our carbon as well into the atmosphere. We can't do this in isolation, and it's only through collaboration. So I was also very aware that the environment plays a critical role in helping to drive forward that green, sustainable industry, that new economy that we really need as well. But to do that, we also need to bring the environment to the heart of decision making, which we just haven't been able to do so far. So I tested these ideas with the Scottish Environment Protection Agency, who at the same time were building this one planet prosperity model. A new way of thinking about regulation. Tested it with Nature Scott, tested it with Scottish Enterprise, and a number of other organisations, all who came back really positive with this idea that really we need to rethink how we do our research and innovation in the environment sector. So that then led to the inclusion of Scotland's International Environment Centre as part of the Stirling and Clacks managed city deal, which was successful, and we believe it essentially £22 million of funding to drive this platform forward over the next 10 years. And that is about all of that area, how we bring that environment to decision making, but also build that skills profile and jobs opportunities in the region in particular. Now, with COVID, it became very clear that the last thing we needed was a new shiny building. And what we needed to do was build a platform for action, a platform for change. And so we moved away from the idea of a new building to actually a platform for the region to really help start understanding the environment in ways that we just haven't been able to. And that's by bringing together partnerships, bringing together data and intelligence on the environment into a single location, a one-stop shop, if you like, so that everyone can access that data and understand what's happening in the environment and help feed that intelligence into decision making. So what we're building then is this fourth environmental resilience array. It's a platform for that green recovery. It's essentially a digital twin for supporting a living laboratory for us to help drive changes in behavior and drive opportunities as well. So we're building this single point of access essentially for environmental data, bringing together existing data that's being collected from research organisations, from SEPA, Nature Scott, Scottish Water, etc., building up that archive, but then also supplementing that with additional data that we'll be collecting. I'll tell you a little bit more about that in a moment. That as a platform itself is world leading. Just bringing that common data set together, which means breaking down all sorts of barriers in terms of licensing of data, data security, etc., to really make that data open and shared as well. So that in itself is world leading, but provides an opportunity in research and innovation that, again, by giving that data up free, is also really fundamental for innovation and business to take that data to also drive new products potentially. So this also will help promote, drive efficient or better decision-making, environmental management within industry to mitigate the impacts they're having on the environment, reduce the resources they're having, drive efficiencies, drive down costs, drive down carbon emissions, for example, and also help support regulation and for industry to go on beyond regulation as well to better that. So the idea here is also to help stimulate new opportunities, new business innovation opportunities as well, fundamentally in that net zero carbon space, so we can deliver that net carbon agenda at pace as well for society, not just for Forth Valley, but also for Scotland. And as I said already, the only way we're going to do this is by working across in partnership with industry, with regulators and policy, with communities and third sector organizations to bring them all together to get understandings and find those solutions. So no mean task, I have to say. It's obviously a big, ambitious program of work. Sorry, went the wrong way. So at the heart of this is water. And it won't be a surprise to anyone here that we're feeling the effects of climate change through water, fundamentally through what we're seeing is, increasing periods of rainfall, intensity of rainfall, separated now by prolonged periods of drought, even in Scotland. And that in itself, those extreme events result in climate shocks, flooding, or even wildfires in the UK. And we've seen that occurring obviously elsewhere. And the propensity for these events is clearly to increase. So that presents us with real challenges. But we're also seeing changes in water quality as well. That complex interaction of increasing rainfall intensity, for example, with changes in land use, are resulting in deteriorations in water quality. In Scotland, we're seeing brownification of water in reservoirs, and nobody wants brown water with humic acid coming into wash basins. But also we're seeing shifts in species, in algae, for example, to less desirable species such as cyanobacteria, toxic, harmful algal blooms. So that sounds all pretty negative, but water is also the fundamental medium through which we can help drive that green recovery as well. So water provides opportunities for energy recovery, be that kinetic or thermal energy, or indeed even hydrogen. It helps us to also provide a platform for that circular economy as well, reducing waste, thinking about how we can reduce waste in wastewater treatment, reducing emissions and so on, fundamentally opportunities for that circular economy. Now, to do all of this, I should also say, if we can manage water as well more effectively, then we can also hold back water within wetlands, within peatlands, for example, and the benefits there are around carbon sequestration. So capturing carbon to offset any residual carbon emissions from industry, for example, and therefore delivering net zero. And that also has the advantages of promoting biodiversity as well, and also the opportunities of also enhancing water quality too. But to deliver on this, we really need to up our understanding of the environment. And unfortunately, really, if we look at the way, even as a science community, we've been looking at and understanding water, we've been doing so in a somewhat compartmentalized way, even a siloed way. Siloed in the far as, we've been either focusing on the freshwater environment or particular aspects of that in terms of discipline, or the marine environment, or issues around flooding, etc. And we really need to think about water in a full continuum. And we've perhaps been biased by geography, biased by a disciplinary bias, biased by finance and opportunity, biased by economic opportunity, but even also regulation and environmental directives. So Forth ERA really is trying to break down all those silos, by thinking about the whole of the water continuum, the surface and the groundwater continuum in particular, and how that flows through our environment, through our natural environment, through the built environment as well. So the way we're doing this is bringing our world-leading technology that we've developed at Stirling, particularly at the global scale for looking at water quality, where we've been using satellites to measure water quality and how that's been changing at the global scale. And I'll mention a little bit more about that in a moment. But also, can we use satellites to look at water quantity, particularly how our soils are wetting up, for example. And if they're wetting up and we know obviously the increasing rainfall potential, then we can also then start predicting flooding and where flooding might also occur. So the satellite technology gives us that full continuum of understanding. But that will happen fundamentally on a daily basis at the moment, or even every few days, depending on cloud cover, given also the orbits of satellites that we're using. So we also need to bring in sensors as well, and sensors can give us that high temporal resolution information at points in the landscape. And so we're bringing in existing sensors that, as I said, already exist from the Scottish Environment Protection Agency, or from the Centre for Ecology and Hydrology, or Scottish Water, and so on, and really bringing that into our network, this, say, one-stop shop. So we're exploiting satellite technology, spatial data, we're exploiting existing sensor technology and new sensor technology to measure variables that we can't get from space, also to validate our satellite data, and to also think about what's happening at depth, for example, whether in the soil or indeed in the groundwater, or indeed at depth in our water as well. But then we have to start asking questions, well, what's happening between those sensors in the landscape? Well, we can't put sensors absolutely everywhere. We need to start thinking about our predictive capability. So we're now bringing in then, to help support that predictive capability, sort of machine learning and that artificial intelligence capability, to then start thinking about what's happening in the landscape between sensors, or indeed between satellite overpasses. We can get that predictive capability. But fundamentally also, we need to think about into the future, forecasting, and also predictive capability going into the future. So what if we don't do anything in response to the climate challenge? What are the consequences likely to be in the environment? Or what are the consequences of some kind of intervention in the environment, promoting peatland restoration, for example? What are the benefits, or indeed, what's the other side of the coin there as well? So we need to bring in that process-based modeling as well into this framework. And all of this will generate a huge amount of data, which is fantastic. But on the other hand, we need to convert that data into knowledge. And we're working with a data visualization company called 3DEO, who are helping us to transform that data into formats which are much more easily, readily interpretable by the whole range of stakeholder communities that we have. And fundamentally, what we're doing here is building a platform for innovation, for new sensors, a platform for innovation within industry in terms of changing behaviors, reducing their reliance on the environment, their discharging into the environment, and promoting that reducing their emissions, particularly carbon, obviously there as well. And that then hopefully will then basically provide the intelligence for better decision making, more informed decision making, driving efficiencies, and as a community and society, grow resilience to the environmental challenges that we have in terms of climate change. Oops, stopped. That's better. So we have been working in partnership. We've been building a demonstrator, which I'll mention very briefly, with British Telecom, BT, particularly in terms of exploiting that communications technology, putting sensors in the environment, and potentially also thinking about new sensor technologies which can really exploit that new breadth of information flow that we can get from 5G as well, so that we can capture and design new sensors and get new intelligence on the environment. But also potentially use 5G to get that data and push it back out to stakeholders in ways that we just haven't been able to do so far, so that we can, for example, use our smartphone and visualize the environment by picking up our smartphone and looking at variables that we couldn't otherwise normally see, but obviously bringing that intelligence also effectively into boardrooms to help to support decision making. All of this has also been co-developed and is being co-developed with a whole range of stakeholders. And although the money has only just started flowing, the deal's been signed, we've launched the centre this week, we've already spent 2 years in discussions with a whole range of organizations in terms of that co-development of this capability. And I'll mention those maybe in a minute, but just to give you an idea of the sort of technologies we're bringing to bear, I mentioned already that, you know, the use of Earth observation for looking at water quality, and we are already doing this. We've been doing it at a global scale. We've implemented our algorithms into Copernicus services for European Space Agency. And now we're also processing satellite data every week for almost 1,000 water bodies across the UK. And we've developed this portal, this information portal, illustrating here, so we can look at water quality in particular for these lakes and reservoirs. So we can identify water bodies which are oligotrophic or eutrophic, for example, in their nature at the moment, in terms of last week. But we can also use the data that we're getting every week on these water bodies from space to understand whether they're increasing or indeed deteriorating in water quality. So as we zoom in here, for example, this is a video that we created a little while ago just to make sure this works. So hopefully you can see that all right on your screens. You can see little triangles here which indicate whether water quality is essentially deteriorating, triangle pointing down, or indeed improving, triangles pointing up. So here just happen to be pointing into Hickling Broad here, for example. And you can see the colours of triangles also relate to the chlorophyll concentration in the water. And so we can do this. We can do this obviously for the whole UK, but and in fact around the world. But what we're doing now is zooming in to do this in particular for Theera, and we're bringing that intelligence into the region. Sorry, it's not showing it particularly well here. So as we go in just to a water body, so this is a video that we've created just to make sure this works. You can see that as you zoom in, we can get data. So this is the month of May and the previous months of May to see how that water body has actually changed its characteristics. So we've got all the data basically for all water bodies pretty much weekly for, let's say, for 1,000 water bodies. So we can see how these water bodies are changing, and we can use the satellite data to see where the problems are in these water bodies. We can drape it onto the map here, for example. If you'll do that quickly now. It's a problem when you have a video. But you can also see the time series of data that we're collecting for these water bodies, which far exceeds anything that's possible through the Water Framework Directive type monitoring, because we have much higher resolution, far more data points than a single sampling point, if you like, for a single water body. And we get that sort of spatial perspective of where the problems are. And hopefully just going to drape that on so you can see how we can actually visualize water in these different reservoirs and lakes and lochs across the UK. I'll stop that now. As you can see, there's lots of data there that we can use, but I'll just jump on a bit. And I'll just show you this one. So, we've been building a demonstrator in the Forth, focused around the Leven catchment. And we've been doing this during the period of COVID. So we've had all sorts of issues in terms of trying to get into the environment to try and deploy these sensors, as well as supply chain issues as well. But these sensors are now going in. And just to give you, they're not all there yet. So this is just a couple of sensors on either side of the Diageo plant, for example, on the Leven. And these are basically measuring the ambient water temperature and also the water temperature being discharged from the Diageo site. So we're collecting data at about 15-minute resolution, and so that we can see how water temperature and turbidity, for example, is changing, and how discharges are potentially impacting on that environment as well. So we can look at this data. There's lots of time series data here, which some people might want to see, but equally we can provide alerts, just simple traffic light systems on this kind of data to identify whether there's an issue or whether things are changing for the better or for the worse. And we also have a MET station which we've deployed in the Leven, which gives us all a range of environmental parameters in terms of MET data, so rainfall data, solar illumination, etc. That helps us understand environmental processes, etc. In the environment. I'll stop there, but you can begin to see what we're doing here is building a platform which will be not only using satellite data for looking at water quality and water quantity, but also augmenting onto that high resolution data as well to really bring in that new intelligence, that real-time intelligence about what's happening in the environment. So these are just a snapshot of some of the organizations that we've been discussing the development of this from innovation centres. And in fact, through Scotland's International Environment Centre, we also have a new innovation centre, the new 5G Innovation Centre, which is going into Alloa to basically exploit 5G technologies for environmental sensing, working with Census, for example, and then a whole range of third sector organisations, the statutory agencies, NatureScot, SEPA, through to industry as well, and also working with SMEs to help develop technologies and opportunities to potentially grow jobs, grow opportunities as well in the region. And this is just some of the examples that some of the things that we've been developing over just over the last 12 months. So I've mentioned the 5G Centre. We've secured the Scotland Hydrogenation Chair, which I've been lucky enough to be appointed to, and that's a £3.5 million investment to help drive that innovation in the delivering on net zero for the whole the Scottish water sector and beyond. We're working very closely with NatureScot in developing use cases of how we can use this technology to not only just monitor the environment, but also monitor and measure the benefits of improving the environment. So if you can measure, for example, carbon sequestration in peatlands that are being restored, that has a value. If you can have a value on that, then that can also promote industry within a catchment to also invest in natural capital within that catchment so that everyone benefits from the improvements, not just carbon sequestration, the promotion of biodiversity, but also the mitigation of extreme events as well. And then we're working with community action programs. We're also working also closely with SEPA, and we've also partners with them along with others on the new Pioneers Fund, Regulatory Pioneers Fund. It's not Regional Pioneers Fund, excuse me there. I say we've been working with BT on the proof of concept, but I also now sit on the UK Water Partnership, which is a quango of all UK water utilities to help deliver on net zero, and everyone, all UK water utilities, UKRI, Sainsbury's, and all the other partners that sit on that UK Water Partnership are looking at the fourth and the innovation that we're driving forward at this point. And it doesn't just stop at the UK. We're also partners now with the United Nations Environment Programme, the World Water Quality Alliance, who see what we're doing here as a real demonstration of what they call this quintuple helix, which is essentially universities and research institutions working together with regulatory policy government organizations, together with industry, together with communities to deliver on the environmental challenges that we have. And we're also now a node of the global Group on Earth Observation, which is an intergovernmental panel that promotes Earth observation to sort out the environmental challenges that we have. And we're now leading on that sort of European node for the GEO, particularly in water quality, primarily because we're involved in a huge number of European projects and European Space Agency projects, which are sort of driving this technology forward. So back to fourth era. So what we're doing is developing a whole series of use cases. I have to say, I really don't like this figure because the whole idea is to break down silos and not compartmentalize the things that we're doing, because everything is connected. Everything is absolutely connected. So I just want to emphasize that here. But just to highlight some of the use cases that we're developing around carbon landscapes, so peatland restoration, wetland restoration, for example, looking at how we're going to mitigate extreme events, and clearly that's all linked together, promoting healthy waters as well. And we're now developing proof of concepts as well in terms of greener towns, around air quality, urban trees, but also increasingly how we can use our urban environment or change our urban environment to become more sponge-like to help capture water rather than channel water away, which then has bigger impacts in terms of promoting flooding, for example. And then also protecting biodiversity, and also the concepts around thriving communities. And we're also working very closely with SEPA in their Regulatory Pioneer Fund projects, which have just started on the Leven and the Grangemouth areas in the Forth as well. But we can give you more details on that maybe at another meeting or a subsequent meeting. But fundamentally, we're building technologies to draw all this together. And one example of that is a new partnership we're forming with a new startup company called Satellite View. Satellite View has a mission now to launch a whole series of satellites which are basically looking at the thermal properties of our Earth's surface at an unprecedented spatial resolution. So what we will be able to do with these satellites, which will be launched in 2023, is look at the thermal properties of our ground, of our surface, at a 3-meter resolution. Now that is unprecedented. And not only that, but we will be able to do that up to 20 times a day, so that we can really get new insights into environmental processes. So, for example, looking at discharges into the river environment, identifying sources of discharges that perhaps we're not so familiar with, or indeed looking at how long these discharges are happening, perhaps, for example. But we can also look at other aspects, such as the thermal properties of buildings, insulation, so we can promote which buildings need to be insulated in terms of improving building efficiency in particular. But also looking at other processes, for example, how natural capital is responding to improvements such as wetlands or indeed peatlands, as I've mentioned. So we block up drainage on peatlands. We can then use this data to understand how these water bodies are wetting up, for example, and the benefits that we're getting from that. And that can then feed into models of carbon, etc., sequestration. So there's all sorts of new technologies that are really exciting that we're building into this program. How are we doing for time? Okay, so just a few final words then, just to say a little bit more about this new program that I'm leading. So as I said, I've been lucky enough to be appointed as Scotland's Hydronation Chair after quite a competitive process, I have to say. And now I'm leading this program to help deliver on net zero for the whole of the Scottish water sector. And as I said, the UK water sector is looking at this program with considerable interest. And the advantage we have clearly is this is funded by Scottish government, whereas maybe the rest of the UK water sector is funded by shareholders and the private sector. So there's real innovation opportunity, really exciting opportunities here for us to drive real change and be a global leader, as in Scotland being a genuine hydronation. So, as I said, that's my mission, and my real mission here is to bring the best of Scotland together in that water sector. That's bringing the expertise from across the universities together to break down those silos, to stop the sort of competitive element, but bring people together to really help deliver on these big challenges that we have. And that's also not just across the university sector, but also bringing together, new companies, SMEs, existing industry, the supply chain to the water industry, together with the statutory agencies and fundamentally with communities and third sector organisations as well. And we will be having a series of workshops called Crucibles to unpack the various challenges that we have. And I also have funding to help pump prime new ideas and initiatives to take those forward and help lever further funding. So the £3.5 million that we have as an investment is really much a start. And what we need to do is return a tenfold in that investment across Scotland, not just Stirling, but across Scotland, to demonstrate how we can drive change at pace. So I'm building a team to deliver on this, and I've just about finished those appointments. And we have a really exciting group that we've pulled together. Fundamentally, I need to be organised. So we've got a good project manager who will be starting in January to keep me organised and the whole of this consortium that we're building organised as well. We've appointed 2 innovation fellows. We've appointed David Miller, who's coming to us from the oil and gas sector with real expertise in decarbonising in that sector. So he brings really phenomenal capability to us and expertise. And we've also appointed Derek Irvin, who may be known to some of you from as a director of the Green Action Trust, who has real expertise in that place-based innovation, which is a really exciting component to this program, which is really about bringing together, as I've said already, those different sectors at the catchment level or within a local level to help identify solutions to challenges that we might have at local or indeed at the catchment scale or indeed at the Scottish scale. So that place-based innovation is a real innovation in itself in terms of a concept we're driving forward here. Then we have the research leader fellows, and I have made appointments in all of these areas, but I can't announce to them yet until all the contracts have been signed off. But we have appointed 2 engineers, one focused on reducing and eliminating emissions, essentially from infrastructure, building the next generation of wastewater treatment works. How do we mitigate and eliminate emissions, or carbon in particular, within that? And then we've also appointed another leader in this area in driving down process emissions as well, and recovering value, that circular economy component as well. The 2 people I can mention are Amy Pickard from the UK Centre of Ecology and Hydrology, based in Edinburgh, who's bringing the resource of the Centre of Ecology and Hydrology behind this as well, and helping to lead on that, enhancing the natural environment aspect here, so natural capital in particular, and how we use that to mitigate extreme events, as well as capture carbon and promote biodiversity. And then we've also appointed Anya Escudero from Glasgow Caledonian, who's already been doing a lot of work in the circular economy, and bring her on board as well to drive those programs forward. So we're just really getting together. The team should be together between December and January, and then we'll be launching a whole series of workshops and initiatives to drive the various challenges and missions that we have to deliver on. So that's, I think, probably my time. I think I hope I've got a few minutes still for people to ask questions, but it just struck me that we really need to raise the profile of the connectivity of our landscape. The fact that we can't think about our environment in compartments, and we do need to think about how we raise that profile. And it, you may have seen these elsewhere, but I really do like the sort of diagrams that we have here, these photographs, which demonstrate the connectivity and how we raise the profile within our communities. And in fact, we live in a connected environment, and what we do in the terrestrial environment impacts on the marine environment and our aquatic environment more broadly. And perhaps plastics, for example, has really raised that profile in terms of, the waste that we generate here ending up and impacting on marine life, marine mammals, especially. But perhaps there's something we can do in our communities, such as the figures, the maps, so the photographs are shown here, that we can help to raise profile. And that's perhaps something we might be able to do together.